All right, ladies and gentlemen, so here we go. Our first chapter, a lot of vocabulary in this one. Remembering to stop, pause the video whenever you need to, and that you can also rewind, watch it more than once, whatever you need to do to be able to get this done here. So, first chapter is a chapter on something called real numbers, and real numbers is any number that you can imagine. All right, so then people ask me, well, are there fake numbers? Well, there aren't fake numbers, but when you get into the high school, you will learn that there is something called an imaginary number. But, so anyway, our first group, we're now going to take these and we're going to group them together and have different categories. So our first group is something called rational numbers. And a rational number is any number that can be written as a fraction. They also include repeating and terminating decimals. So, for example, you can have the number 1/2, right? There's a fraction. You could have the number -15, because all I need to do for that, if I want to turn it into a fraction, is put it over 1. Okay. You could have the number 0.3 repeating. You could have 5.67. Right? Those are all types of rational numbers. All right, integers. Integers are positive and negative. That's supposed to be an and symbol. Oh. What? I don't know why that's happening. And negative whole numbers. So, for example, right, we can have things like 0. 0 is an integer. We can have things like -15. We can have +37. All right, those are all examples of integers. Whole numbers. Whole numbers are positive numbers, including 0. Right, so the whole numbers are 0, 1, 2, 3, and I'm going to put ... to continue that. All right, so we have no negatives for whole numbers. Counting numbers are numbers that you can count to, right? So they start with 1, and then they go up. 1 and higher. All right, so for example, we can have 1, 2, 3, 4. So notice the difference between whole numbers and counting numbers. Whole numbers have the O, the 0. Counting numbers do not. All right, an irrational number is any number that cannot be written as a fraction. They include decimals that do not terminate and do not repeat. Oops. Do not repeat. Some examples, right? Our most common example of an irrational number is pi, which hopefully we remember from last year. It goes on and on and on forever and ever and ever. We can also have these things that are called square roots of numbers that are not perfect squares. So the square root of 3 is an example. You can have something like 5.101001000 ... Oops. Right, there isn't a pattern there. It's not a repeating number. All right, let's see how these all relate to each other. So our big category here are the real numbers. That's the big category. And then they're broken down into 2 separate things. Rational or irrational. Right, so our rational numbers, positive and negative fractions and decimals. So let's put some examples up here again as well. So you can have -5/3, you can have 16, you can have 3.3 repeating. Those are rational numbers. numbers. Integers, I'm going to add in here, no fractions or decimals. For your whole numbers, right, whole numbers, you're going to have no negatives. Natural numbers, no, 0. Irrational numbers, you're going to have things, again, we'll put in our pi, we'll put in our square root of 37 this time, we'll make a negative 2.658 ... Down here, note, underline it, highlight it, do something, box it, whatever. A number cannot be rational and irrational at the same time. It doesn't work. That circle got split. Okay? All right, let's try some practice here and see what we got. Are the numbers rational or irrational? So I don't want to know anything else. I just want to know rational, irrational. Rational are things like our fractions. Irrational are not fractions. Okay, so negative 15 over 3, it's a fraction, rational. I'm going to abbreviate it, right? Why? Because it's a fraction. We have 4.67, rational. It's a terminating decimal. 6.3, rational. It's repeating. Oops, sorry. There we go. Repeating. Pi, irrational. All right, and we're going to do the other ones together. We'll talk about those. Next group, circle all of the vocabulary words that represent each number. So, first thing you have to decide is it rational or irrational, right? This is either or. You can't have both of those. So 0 is a rational number. If it's rational, then you have to decide what other categories it fits into. 0 is an integer. 0 is a whole number. 0 is not a counting number. You do not count to 0. All right, negative 6.7777. Rational or irrational? Well, it stops, it terminates. That makes it rational. Is it an integer? No, because it's a decimal. Integers, no decimals or fractions. Once you say no, then you stop. You don't even have to worry about the whole or the counting. All right, 4 plus pi. Well, even though it has a 4, it has a pi. And as soon as you have a pi, irrational. And remember, in our picture, there were no other subcategories here in irrational. That was it. All right, so over here. Sorry, moving down. Okay, radical 16 over 2. Well, the square root of 16 is 4 divided by 2. 4 divided by 2 is 2. So sometimes you might have to simplify those to see if you can, see if it'll go down any further. So this one is rational, right? It's a whole number. It's an integer. It's a whole number. It's a counting number because I can actually count to 2. All right, and then we're going to do the 12, 13, 14, 15 together in class. All right, any questions? Bring them with you. Otherwise, have a good night.